To analyze two objects graphically, we have to make the connection that the slopes of their lines, their respective lines, must be the speed of these objects. So in my example, I'm going to assume that one of my cars, the fast one, moves at 50 centimeters per second and the slow one moves at 20 centimeters per second. Once that's been established, I can simply draw a line that has a slope of 50 to represent the fast car and a line that represents 20, or that has a slope of 20 to represent the slow car. So things become much simpler if I realize I can simply just draw lines that have these specific slopes. Yours will certainly be different based on your cars, but I'm going to go ahead and use 50 and 20. So if we go to Logger Pro, you can do it by hand, but if you prefer Logger Pro, I'm going to plot the fast car. Mine moves at 50 centimeters per second, and my slow car, which moves at 20 centimeters per second. And the first challenge problem asks you to place them 3 meters apart, also known as 300 centimeters, point them towards one another, and then turn them both on. And we want to predict when they're going to collide. So I'm going to plot both of them on the same graph. If you're not sure how to do that, just check back at one of the other videos that will quickly show you how you can add multiple data sets onto a Logger Pro graph. Now the fast car, I need to kind of come up with a starting point, so I'll just make 0 the starting point for my fast car. So I say after 0 seconds have elapsed, after I haven't turned these things on and moved them, that car is quite simply just sitting at what I'm defining as 0. Now, at 0 seconds for the slow car, we have to ask ourselves how far apart are these cars to begin with. So we're told that they need to be 3 meters apart. My graph is in centimeters, so 3 meters is 300 centimeters. So if I plot a point at 0, 0 to represent my fast car, and 0, 300 to represent my slow car, what we have just done is show that they are 3 meters or 300 centimeters apart at time equals 0, when I have yet to actually start this exercise. Now all I have to simply do is add points to each of these that will give me the desired slope. So we'll start with the fast car. Now we know that the fast car moves at a speed of 50 centimeters per second, which means the slope of this line must be 50 centimeters per second. So the easiest way I think to do that is to go over 1 and then up 50. You could have certainly gone over 2 and up 100 or 3 and up 150, but the rise over the run must be 50. So my rise being 50, my run being 1 second. If I connect those two lines, that is going to give me a slope of 50. So if we look here, I have a second point here, and the other one needs to have a slope of 20. So the second car is going backwards, so I actually need a slope of negative 20. So after 1 second, it will have gone 20 centimeters in the backwards direction. So it was at 300, so now it will be at 280. So you can see up here, this car is actually moving backwards as time goes by, and this one is actually moving forwards. So now all I need to do is, using my curve fit tool, let's add a line of best fit for the fast car. We'll use linear because we're just trying to represent it with a straight line with a slope of 50 in this case, as you can see here. And then I could do the same by clicking on curve fit and going to the slow car. But the slow car needs to actually have a slope of negative 20. So I do try fit, I can double check, negative 20, we're good. I'll slide these out of the way. So what you'll notice is that this car is moving forward, this car is moving backwards, but they have yet to intersect. So I'm going to go ahead and I'm just going to keep zooming out here until eventually I see this intersection point over here. So your numbers will probably work a little bit better than this one because your cars have different speeds. But if I look at this one, which has a speed of 50 centimeters, it will occupy the same position as the other car right about here. If I just put my cursor over that location and then I check down here in the bottom left-hand corner, I can see that I can expect these two cars to collide after 4.301 seconds, so after about 4.3 seconds, and 211 centimeters from the origin, which is where my fast car is. So if I line that up there, I can assume roughly around 4.3 seconds and around 212 centimeters from the fast car, we would expect these two to collide. All right, so you can do this as long as you know the slopes, the speeds of two cars. You represent them by plotting a line that has that slope. Make sure your direction is pointing the right way, and then you're looking either for an intersection point or, depending on the scenario, whatever specific thing you're trying to analyze. So in this location or this example, we have a car that's moving upwards at 50, a car that's moving downwards at 20. They started 300 centimeters or 3 meters apart. And as you can see here, they converge at one point. They both try and occupy the same position at the same time. And that is also known as a collision.